My name is Kiran Kumar. I am a physics lecturer. Today topic is apparent depth and a real depth and also apparent normal shift. Now welcome to my channel Nature of Physics and Art. Light traveling from the denser medium to a rarer medium, it bend away from the normal. See, O is the object that releasing the light and light bend away from the normal. I is the angle of incident, R is the angle of refraction. Extend the emergent ray that is taken as refracted ray here, then that coincide at a point I is the image of the corresponding object. Now OA is the real depth and IA is the apparent depth, and here A is the apparent normal shift that is representing OI here. Okay, and derivation before going to that, A is the apparent normal shift and here apparent depth is IA and real depth is equal to OA. And Snell's law, what is Snell's law? The product of the refractive index of medium and sine angle which is equal to constant. See now here according to the Snell's law mu W sine I which is equal to mu A sine R. Now sine I divided by sine R which is equal to mu A divided by mu W. Okay, and here sine I which is equal to AB divided by OB and sine R which is equal to AB divided by IB. Values are replacing here. Sine I value is AB divided by OB whole divided by AB divided by IB, which is equal to refractive index of air is 1 divided by refractive index of water is taken as mu here. Okay, so here AB is get cancelled and continuation equation IB divided by OB which is equal to 1 divided by mu. Here A and B are very near. A and B are very near points. Actually, for derivation purpose we are considering certain distance between AB, but actually A and B is very near, so we can modify the values here. IB is taken as, this is IB is taken as IA approximately equal to, and next one is OB is approximately equal to OA. Then the values here IB is IA which is divided by OA which is equal to 1 by mu. Now IA which is equal to OA divided by mu. So here IA is apparent depth which is equal to real depth divided by refractive index. Now we can write the equation in the form of real depth. Then real depth which is equal to mu into apparent depth. Mu into apparent depth. Real depth is equal to mu into apparent depth. And continuation equation real depth is OA which is equal to mu into apparent depth is IA. So now we got four equations relation between the apparent depth and also real depth. Now apparent normal shift. Here A is the apparent normal shift. So A which is equal to, according to the diagram, that value represent OI. Here OI which is equal to OA minus IA. Try to understand. Now here A which is equal to OA minus IA value is replacing here, that is OA divided by mu. So A which is equal to OA common, then 1 minus 1 divided by mu. So we know OA value is thickness that is taken as T. So A which is equal to T into 1 minus 1 by mu is the apparent normal shift. For example, instead of air, we can consider a medium, that is if mu a which is equal to mu dash, then the values will be changed, that we will discuss now. So here apparent depth, that is Ia which is equal to OA divided by mu dash. Here actually mu divided by 1, but refractive index of air is equal to 1 taken there, but now we are considering mu a is equal to mu dash and rearranging the equation, that is Ia which is equal to mu dash divided by mu into OA. Okay, and here also we can write apparent depth which is equal to mu dash divided by mu into real depth. Okay, and also here real depth which is equal to mu dash by mu, we have to write here. Then once again listen to me. Now here real depth which is equal to, that is mu into apparent depth, here mu divided by mu dash into apparent depth. Okay, so now equation, the real depth which is OA which is equal to mu divided by mu dash into Ia, and also we can write in the apparent normal shift. For apparent normal shift, writing here, so A is equal T into 1 minus 1 divided by mu dash. Now A which is equal to T into 1 minus mu dash divided by mu. Okay, this is the apparent normal shift. Okay, so we can discuss applications. Now the relation between the real depth and the apparent depth based on the diagram. So that is, we are considering as a graph. Here on the x-axis considering real depth and y-axis considering apparent depth. So here apparent depth and real depth relations. So apparent depth Ia which is directly proportional to the OA, and from this equation real depth is also directly proportional to the apparent depth. That's why here the straight line passing through the origin and theta is the slope of the graph. Then we have to find the relation, that is Ia apparent depth which is equal to OA real depth divided by refractive index of water. So here Ia divided by OA which is equal to 1 by mu. Actually here we are considering air as a medium, refractive index is equal to 1. But if air refractive index is taken as mu dash, then we can take Ia divided by OA which is equal to mu dash divided by mu. Here instead of 1 I am writing mu dash because of refractive index of air is taken as mu dash. Okay, this value is replacing here. Then tan theta, so tan theta which is equal to opposite, that is apparent depth divided by real depth. So this is real depth. So try to understand here tan theta which is equal to, the relation is Ia divided by OA. Now tan theta which is equal to, that is 1 by mu, and tan theta which is equal to mu dash by mu. So this is less than equal to 1. So this is the diagram for the relation between the real depth and the apparent depth. And next application. Now considering two objects O1 and O2 in a denser medium, that is water. These two objects O1 and O2 separated by a distance h Now corresponding images I1, I2, that is separated distance is taken as h dash. Now we know one relation, the apparent depth which is equal to real depth divided by a refractive index. So apparent depth which is equal to real depth divided by a refractive index. So instead of here apparent depth I am writing I1 I2 which is equal to, instead of a real depth, that is O1 and O2 divided by mu. That is a relation between the image height and the object height. That is I1 I2 represent image height h dash which is equal to object height is h divided by mu. So this is the relation between the distance between the I1 I2 images h dash which is equal to object height O1 O2 divided by mu is the refractive index. And next application we will discuss continuously. Now we will discuss apparent depth of object due to a composite slab. See, considering first material of thickness T1 and refractive index mu1, and second material T2 thickness and refractive index mu2, and third one is T3 and refractive index is mu3. Listen to me. So the basic formula is apparent depth IA which is equal to real depth divided by mu. So for this only one medium, but here many mediums are there, three, that is T1 thickness, T2 thickness, T3 thickness, corresponding refractive index mu1, mu2 and mu3. See, try to understand. Using this basic equation I am going to write apparent depth IA dash which is equal to, that is first one T1 divided by refractive index mu1 plus T2 divided by mu2 plus T3 divided by mu3. This is the apparent depth of the object due to the composite slabs. So continuation we can also discuss the apparent normal shift for the three different medium slabs. For this, considering basic equation for the apparent normal shift, A is equal to, that is T into 1 minus 1 by mu. So now basic equation based on that, that is apparent normal shift of the composite slab is A dash which is equal to T1 1 minus 1 by mu1 plus T2 for second 1 minus 1 by mu2 for third plus T3 1 minus 1 by mu3. This is the apparent normal shift. These are the special cases of the apparent depth and real depth. Thank you very much.